Hi, I'm Antonios, a senior software engineer at Hopsworks, and today we're going to see the high availability capabilities of Hopsworks platform. But before we go into the terminal and we see how it works, let's do some drawings about the architecture of Hopsworks. So in this scenario, we have here one machine, which is the Hopsworks REST API. And then we replicate it 3 times to achieve high availability. And in the same machine, we host also the database, the metadata database. Right? And then these are in the same machine. And then on another physical machines, we store the online feature store. And the reason for that is that the online feature store, it serves critical services of an organization, so it must remain always online. So we also set 3 machines for the online feature store. Now, what these machines have here, what these machines they have, there is Kafka brokers here, and here, and here. So that gives us high availability in terms of Kafka. Now, the online FS itself, it's a containerized application. It's a microservice architecture. So these are Docker containers, and they're stateless Docker containers, so we can launch them. We can have multiple for redundancy. Also, in this machine, we store the online FS, the online feature store databases. And again, this is a highly available RunDB database with 3 data nodes storing your data. And what gives us is even if 2 out of 3 they die, then we can still serve your data. Now, because although this is enough for some customers, a few of them, they have the requirement to be replicated in a different region. So we are also going to demonstrate in this video how to do it. And for this, imagine that this setup here is actually in EU, and the other cluster is actually in the US, which has exactly the same. It's a replica of the EU here. And what's happening is the Kafka, for Kafka brokers, we use Mirror Maker. Mirror Maker, so all the events are streamed to the US. And so the events in the Kafka, they're streamed in the US, and then the online FS pools these events and eventually writes them to the online FS RunDB. And same is happening here. And then here we have RunDB. Now, for the metadata layer, Hopsworks is running, but is running in a standby mode. And the metadata, they are asynchronously replicated to US region. And that is because of the higher latency between EU and US. So here we have RunDB replication, asynchronous replication. And also on the top, we have a load balancer, which is an HA proxy in our case, to route traffic either to EU or US for the active standby services, or to both in case of online of the online feature store. Now, when we go back to the computer, the terminal in the EU region are going to be blue, and the terminal in the US region they're going to be green. And the network is going to be 10.1.40/24, and then here it's 10.2.4/24. So now we're going to show you Hopsworks. And as we said earlier, the blue terminals here, they represent the EU region, and the green terminal here, they represent the US region. And as a matter of fact, we can see the availability zone here, and you can see that this is the US East 2, and on the blue one, you can see that it's the EU North 1. So everything is behind the load balancer, and if I go to my browser, you see that I go to the www.nuke.devcloud.hops.ai, and I have already created a project called VM-Stats. And what I'm going to show you now is a feature engineering pipeline, which is very, very basic, but for the purpose of this demonstration is enough. So what happens is I will start a Python producer on one of the machines that will just gather CPU metrics and memory consumption, and then they will push them to a Kafka topic, and then there is a streaming job in Hopsworks, which will take these and then write them to the online feature store. Then I will also run another script, which will go and it will query the online feature store and always show the freshest metrics. So without going into much details, here you can see the script, the scripts for producing. It's basically taking the host name, the software interrupts, and the free memory, and then write them to a Kafka topic. And then the validate script, similarly, it just goes to the online feature store, and then picks all the features as a pandas data frame, and then sort by event time and prints the first one. So before we start killing services, I will start the producer. So on this terminal, I start the producer, and as you can see, it has already starting to producing events. Then on the other terminal, I will start the Python script called validate, and it will start printing the latest event. And as you can see, the event time changes, the number of software interrupts changes, then the free memory changes. So far, it's a very simple feature engineering pipeline. So nothing much, nothing interesting in that regard. So the first thing that we're going to try, as I said, we have 3 Hopsworks instances, 3 Hopsworks servers, and we're going to start killing one of them and see what's going to happen. And then so now we're stopping one instance of Glassfish. Normally the producer script, it will continue to work. The validator script, it will also continue to work. Yeah. So the glitch that you saw here is because the server died. So it failed over to the other one. As you can see here, the server here is inactive. Now, the second thing that we can do is kill one of the databases for the online feature store. So as we said here, there are 3 databases to provide high availability, and if we kill one here, then the data is fully replicated on the other 2. And this should be dead. And then we see here, if we continue polling our validator script, then we can see we still get the fresh data. Now, regarding the metadata, as we said here, the latency between EU and US region is quite high, and it might if we place data nodes on the same of the same cluster in different regions, some transactions might get aborted. So for that reason, we opt to get the asynchronous replication. And for that reason, we have 2 replication channels going from this server here on that one that's doing the replication. And then for high availability, we have a standby channel going from this one to this server here. So what will happen is we will kill this replication channel, and then we see the other one taking over. So let's go and do it. So let's kill the MySQL database that is doing the replication right now. And this one is the service here. It happens that the replication is initiated by the US region. So the US is pulling the EU. So here we stopped the MySQL server on the active MySQL server on the US region. And we can see here that if we tail the logs of the monitoring thread, oops. Then we can see that the replication, that this server now has taken over the replication. And in fact, we can go ahead and create a project. We can call it demo A. And what we expect to see is the project metadata, they're being replicated in the US region. So if we go and do select star from Hopsworks, let me zoom in for you so I can see better. You can already see that the demo A project has been replicated on the other side. Now, what will happen if we also kill so now what happened is we have killed this replication channel, and the other one was taken over. So what we can do is also kill that replication channel and see what's happening. So we also kill this server. And while this is dead, we can go and create a demo B project. So the project creation will succeed because this is happening right now. The active region is it's EU, and that one is decided by a service what we call JUD. So we see that we have a service in Hopsworks called JUD, which at any point in time you can query it. It's an HTTP service, and it gives you back which is the active region at the moment. And we can query it with this. So right now we see that the active region is the EU and the secondary is the US. So remember before we created a project called demo B, but then we have also killed the replication. So normally we wouldn't expect it to appear on the US region. And as a matter of fact, you can see here that it hasn't appeared yet because the metadata hasn't been replicated. Now, what we can also do is we can see, so for monitoring, we use Prometheus, and we also use Alert Manager, and we have configured rules. So in case the replication goes down, then and any other service dies, then we can get alerts to our preferred notification system. For the purpose of this demo, I have set up Slack. So we can see you see that we have received an alert on Slack that actually the replication has been broken here on a Slack, and then your ops team can go and start it up, which is what we're going to do right now. So what we just have to do is start the MySQL server on both machines in the US region. And then one of them will automatically be elected as leader, and it will start back the replication channel. And eventually, we will see that the demo B project metadata has been replicated over to the US region. So if we check let me zoom in again. Sorry, hops. So now we can see that the replication has caught up, and actually the demo B project, it has appeared on the US side, and at some point we have and also we have received right now a notification on Slack that the replication has actually been resolved. The replication issue has actually been resolved. So that covers the metadata part. Now, remember that we write, in the beginning, we started the process in the EU region, where we are writing this metrics into a Kafka topic, and then eventually they reach the online feature store. And then we have a Python script on the other, again on the other terminal, which validates that we are actually getting the freshest. Now, as we said in the beginning, there is a mirroring between the Kafka processes in the EU region to the US region. So we can see that if we go to one of the, because the data that we are doing, we're not doing any kind of aggregations or any complex feature engineering. It's just sufficient if we go to the online feature store database on the US region, and we just query our data. So let me do that. So databases. And every project has its own database. And then every feature group, it has its own table in the online feature store. So now, so if we go on the MySQL server of the offline feature store in the US, and we execute the same query that we do on the Python script, we can in fact see that we receive the latest statistics for the CPU interrupts and the free memory, and we can verify it. We can see that the event time is changing, the CPU interrupts are changing, and actually they are they are in line with what is happening in the EU region. Now we can also go ahead and kill randomly servers, data node servers on the online FS part, on the online feature store, and we can see that actually this is not interrupted at all. The service is not interrupted, and we will receive a notification on Slack that something is wrong. And as we see, the ingest has not been interrupted. And also in the US region, we can see that we are still getting the events. Now, as we said earlier, some of our services in the Hopsworks platform, such as the online feature store, they are basically active-active. So they're both receiving the same events. But some other services, such as the offline feature store, they are active-passive. And who is active and who is passive? It's decided by the judge. So in case of a catastrophic failure and the whole EU region goes dark, then what we can do is we can have processes where the load balancer, it changes everything and redirects from EU to US. And for the purpose of this video, I have made it quite simple. I will open a pull request to a repository where we keep which region should be active. I will change the active region, and then normally I will push it. Somebody will review the pull request, merge it, and then we should see that the judge has actually automatically changed who is active and who is passive. So if I go back into my terminal, let me zoom in. I create another branch, and I change this JSON file, and I say that the US now, it should be the active one. I commit it, change active region. So then I will open a pull request. And then normally somebody in your organization will review it and say that everything is okay, and then I will merge it. And then if I go back to my terminal and I do the curl command again, we can see now that the judge had decided that the active region should be the US instead of EU. And if I go and check the status of the name node, which is a central component of the offline feature store, I can see, I will see that in the EU, it's dead. And the reason for that is because the judge has decided that these services shouldn't be alive anymore, and it should die. And instead, on the other hand, in the US region, the same service, it was dead before, and now we can see that it's active. And then we see in the US region that the same service, it has actually started, and it is running. So finally, if we go, now that we have changed the active region to be the US, if I go back to my browser and I go back to Hopsworks, we can see that I can actually navigate and check all the feature groups and see my jobs. So, and change to the VM stats job, and I see that this one, so the streaming job, it's continue to be running, and the offline materialization job, which runs, I have scheduled to run every 2 minutes to materialize them to the offline feature store. It's about to run. So with that, we conclude this demonstration of the high availability and robustness of Hopsworks. So what we saw today is high availability in a single region, which covers 90% of the use cases. But for the extreme high impact solutions, then Hopsworks also provides data replication on a secondary region, where for the most important and critical components is active, whilst for other components we can relax a bit requirements and it's active-passive. So thank you for watching, and I'm looking forward to your comments and answering your questions on Slack. So feel free to ping me personally or any of my colleagues. And yeah, thanks again for watching and have a nice evening. Bye.